Hi, hello and welcome to this week's lecture in ESP, Introduction to Programming. Today we have a bit of a different setting. So I'm in Graz, but Sebastian, where are you?
Yeah, hi everyone. I'm currently in Munich at a very interesting conference. Unfortunately, not in Graz, that I could join you, David, but I'm happy that I could join online. So yeah, I'm really looking forward to this lecture today.
So I hope this also works where we have this separation line between us. But maybe you can give us short feedback in the chat if the sound is still good for both of us, because we have like an interesting setup. And I hope you can understand us both very good. Okay, looks very good, great. I saw, before we start, I saw one question already in the chat, because design your own app and what's the problem here. There is a section also in our FAQ section on our course website discussing that. But basically, when you do the learning C part in design your own app, you should attend the ESP lectures because they prepare you for this learning C part, but it's non-mandatory as it is ESP in general. So it's just like, the idea or the recommendation for you to attend the ESP lectures to be prepared for this learning C assignment you will get afterwards. All right, yeah, I think we have a lot of content for today. So let's get started directly. We are in week 1 and we're discussing today data types, variables, operators, and we will start with our first program. So this will be maybe the first time many of you see a C code or a source code in general. So I'm very excited about that. I can remember my first line of code and my first program. So it's like a small milestone in everyone's programming career. But before we do that, let's discuss some organizational part. We also saw some things already in our practicals a few minutes ago, but just to sum it up once again, we have this student consulting program, which is an additional support possibility for you. And there we have experienced students that can help you with coding, can help you with ESP in general. But be aware they are not tutors, so they are students who passed ESP the previous years, so they have quite good experience with ESP and know what's important. So such a consultant, we called it also sometimes buddy or a mentor, has about 8 to 10 students to coach. It depends on how you or how many interactions you want. And if you want to have such a consultant, please register here at this link. We will, by the way, also upload the slides afterwards to our course website. And you can also use this QR code. You will come to a form where you can just register for this program. And I think in the next few days, we will then email you and create the contact with your consultant, and then you can ask them questions. It's sometimes so that there might be the case where you don't want to ask us, the people who are grading you, but you have a question, and then you can ask these students. They will not write the assignments or write code for you, at least they should not. But if you have general questions, they are very happy to help you. And another thing is the weekly exercises. I think in the practicals you already get a good understanding what the weekly exercises are. So this is just the basics and the most important information together in one slide. And if you have problems, please contact us on Discord. We will release the first weekly exercises today after the lecture. So you can focus now on the lecture, and after the lecture, I think at 6 p.m. 15, then we will publish the weekly exercises on the GDP. You have enough time. I think it's until the 4th of November, something like that. it's the assignment 1 deadline. So still a lot of time, but we would highly recommend to learn each and every week with us, because it is created that we are holding the lecture, then you can do these small exercises, maybe doing the practicals next week where you get additional information, and then retry the weekly exercises again. So they are meant to be like a weekly exercise for you to join and to keep up to date with the content. And we will also start with the coding sessions next week on Monday. And for that, we will release the homework today. So the coding sessions take place in the next 3 weeks. So you have a lot of time. You can choose whenever you want to participate in the coding session in the next 3 weeks. So you register for a time slot in the Teach Center. Then complete the homework, which you might find the practicals today very helpful, because basically what they were telling today is the homework content. So if you're struggling with the homework, I would highly recommend you to watch the practicals today, because they showed everything about it. And then you should submit your solution before your coding session starts and attend the coding session. As I said, the first coding session starts with next Monday, but you have like three weeks of time to participate in the coding sessions. And we also discussed that last week a bit about plagiarism, and we do not want you to post your solution or your source code. And that's also the same with the homework. So if you have a solution for your homework, please also do not post it somewhere on Discord, Telegram, WhatsApp, whatever, because you should solve it on your own, and it's a good practice for you for the upcoming assignments there. Anything to add from your side, Sebastian?
Yeah, just one additional thing. We should also mention that we offer personal question hours. So it's possible for you as students to book a slot or to just attend then the personal question hours. And especially in the beginning of the semester, it's always, we have some problems with the virtual machine, with Docker or whatever. And personal question hours are a great opportunity to solve these problems and also ask whatever you need.
It's especially for the setup for the virtual machine, SSH key and so on. It's in the beginning quite hard, and you can come to the personal question hour and they will help you. And I think Julia is also there next week, so she's like the expert for all these questions. I just saw, Sebastian, that I'm very bright and it's a bit dark at your side, but I think it's just the lighting here.
Yeah, unfortunately, it's not possible to make it brighter here, and the weather is also not that good, unfortunately.
Yeah, it's the same as
I hope it's still. Yeah.
All right. I think that's all from the organizational stuff. And now we should start with, let's say the most important program of all time. And one of the brains of our time, let's say it like this, said the Hello World program is one of the most important programs ever written. Who was it? It was ChatGPT, and asked it today. So fair enough. But it is actually a true, like a quote, as far as you can say it, or as far as you can quote ChatGPT. But he wrote it today, and I found it quite funny that I want to put it into my slides here. So what is the Hello World program? The Hello World program is, let's say, in each and every programming language you will first see this Hello World. And this just means it's a statement that prints out Hello World. And you get a feeling of the syntax of C in this case, or the programming language in general. And the output is always the same. It's hello world. Yeah, that's basically it. There is a lot of additional stuff into it. There is this int main, these two brackets here. We have this curled brackets here, opening and close. We have this printf here. We have this text inside, and we will come to that step by step. But at first, let's say this is the most basic program you can have in C, and it's always hello world, so printing out hello world. But when we want to write such a program, we need a program to write source code. And it's similar like you writing a text. You need, for example, a text editor, or you need Microsoft Word if you are more advanced. And in our case, we are using VS Code, for example. And VS Code is a program that helps you writing code. And it has a few components. If you open it, and by the way, it's also installed in the virtual machine, you have on the left side a file section where all your files of your current folder are listed. You have here the editor section with the hello world statement. So here you can really write your source code. And below you have this terminal section. And this is pretty much the same terminal you just saw in the practicals, because here you can interact with the operating system and type in all these fancy commands you have seen before in the practicals. For example, changing the directory, creating directories, or what's even more important for us when we write computer programs, we want to execute the program. And when we want to execute a program, we have to do something like this. We have two steps, basically. The first one is in C, we need to compile a program first. Compiling means, in very general words, you have this source code file, which is human readable, or at least programmer readable. And you have to convert it to a machine readable file. And this is what the compiler does for us. So it converts the source code file to a machine readable file so that the computer can read it. And you do that by calling the compiler. In our case, we use Clang compiler. We have this -v_all. We will come to that, what this means. And then we have our file name. So when we go back, in this case, it would be helloworld.c, because this is our file we want to convert. And then we write -o. This stands for what should be the output file, so the executable output file. And then I can add a program name. So in this example from before, we write Clang -v_all. This, by the way, stands for all warnings. So we activate all the warnings when we have problems or errors in our source code. This means that it will show to us if there are errors. Unfortunately, it cannot see all the errors, but some of them. Then we write the C file, and with -o and then hello world, we see the output file. So this is basically the file which is then machine readable, and with /hello world, we can then execute it. And as you can see, when we execute it, it's basically what we have seen before. It's in this case just hello world. We will talk about the compiler in a few lectures more in detail, but from now on, this is what you need to know. So we need to compile and we need to execute a program, then we see the output. We also use another editor for writing code, and this is online GDB. And the great benefit of that is that you can execute it online. So you can just open your browser, write the code here and execute it. So you don't need a virtual machine, you don't need VS Code installed and so on. This is very good for small programs, and this is also why the weekly exercises are an online GDP. But I would not recommend to write bigger programs like the assignments in online GDP. I would highly recommend using the virtual machine and VS Code because this has some limitations. You will see there are a few differences, but for small code parts, online GDB is a good alternative. And you also have here different sections. You have some control buttons on top. You have the run button where you can compile and execute your program. So you do not need this step separately. You can just compile it and then execute it. You have this editor section where you can write the code, and you have the output section where the output is executed or can be seen in the end. And I can also switch now to the online GDP. It's here. I hope you can see it. And this is, as I said before, a very basic Hello World program. And if I run it, I can see here, okay, it's printed Hello World. Let's change this to Hello Sebastian. Run once again. And yeah, it worked. So I changed already my first program to a more advanced concept. Yeah, let's say more advanced.
Hello Online GDB.
Hello Online GDB would be better, yes. All right, so this was already our first program, but we are not finished with C programming. Yeah, that's not all, unfortunately. We want to do so much more. But yeah, we should go one step back and talk about computer science in general. But before that, are there any questions in the chat, Sebastian? Have you seen something important?
There's one question, maybe a bit more related to the practicals. Is it recommended to also use minus W extra and minus pedantic? Because last year I didn't use them and I got warnings and lost points.
Yes, you should use it. It's also included in our make file. I know you maybe not know what a make file is, but this is basically automatically execute this compiling, what I showed you before. And you should use these flags, but if you don't know it currently, no worries, we will come to that afterwards. It's only important at the assignments, and we will talk about that when we release the assignments.
Yeah, but I think that's all for now.
Great. Then let's talk about computer science in general and what is it in general.
Yeah, it's really cool. So we've just programmed our very first own program and executed it. But if we now remember last week, we said that computer science is more than just programming. It's, for example, also about problem solving. So in the most cases, we have some kind of input, then yeah, some kind of magic happens, and at the end we have some output. And now if we are talking about input, magic and output, we need something, and this is then called data. So if we go to the next slide, we can now think how we can use data, what is data, and how we can use it in programming. Well, for now, for that we now introduce some data types or some variables. We have here a list, so it's an inventory ID, category, description, unit price, quantity in stock, inventory value, and reduced price. So we have different data. And yeah, we can see there are some numbers, there's some text. Okay, category, that's quite interesting. So exactly, if you now have a look at the single columns, so the very first column, inventory ID, if we have a look at the specific values, there are a mixture of characters. So in this case, some letters and numbers. So the first column is a text. The second column, it seems like we have just 3 different values, and all of these values are one single letter. It's either A, B, or C. So one letter is just a character. The description, yeah, this consists of multiple words, so we just call it text. Then the next columns are very interesting. We have different types of numbers. We'll come to that in a few slides, how they differentiate. And also very interesting is the last column. It's the reduced price, and it's only yes or no. So we just have either yes or no. It's a binary value, so it can be a reduced price, but it can also be a not reduced price, but it cannot be the same at the same time. Okay, well, that's quite interesting. So we now continue. We have some different terminology in programming. So we don't really use number or text, but we use something else. For example, for the first column, which we called text before, we call them strings. We'll come to strings and all the other data types in a few slides. If we continue, the next one is a character. So that's the same term we have used just before. Similar or exactly the same as the first column, also the description is a string. So it's a concatenation of single characters, or it's just a bunch of words. And now it gets really interesting. So let's come to the unit price. It's a float. It's a floating point. So in German, we call them Gleitkommazahlen. So we have something right to the decimal point. And for the quantity in stock, for example, we don't have that. So this is an integer. It's in Deutsch a ganze Zahl. And if we now have a look again at the inventory value, it's quite similar to the unit price. It's again a float. And yes, now we come to the reduced price. That has a special name. It's a bool, a Boolean value, which can either be, in this case, yes or no, or in programming, true or false. Okay, yeah, that's really cool. But this is just data. How can we use it in our programs? For that, we now introduce variables. And variables in programming are just named storage locations that hold some kind of data values, as we've seen in the table before. And with these variables, we can now store a data value, we can modify the value, and we can, of course, also retrieve just information about this data in our code. And yeah, as the name suggests, in general, the value of a variable can change during a program execution. So you can, as we've said, modify it, store it, and just retrieve it. And essentially, variables have 3 important properties. In order to store, modify, and retrieve some value, this value needs to be stored somewhere physically, which means it needs a memory location somewhere in the computer. And of course, a variable should also have a value. Otherwise, it wouldn't make that much sense. And ultimately, a variable needs to have a data type. But yeah, what's a data type? So in the C programming language, and of course in many other languages, we have a bunch of different types of data. And we can even name them. Let's start with a very straightforward type. It's the Boolean type, or short bool. It can hold one of 2 values. In C, it's either true or false. It's very straightforward data type, but it is also very useful. You will see that when you program. Now a character is one single letter. It's a number, a symbol, or it can even just be a space. And this is the smallest unit of text in programming. If we now move on to numbers, in the C programming language, and also in many other languages, there exists a data type int. It's short for integer, and in German, as mentioned before, it's called ganze Zahl or Ganzzahlen. And maybe you're familiar with this term from one of the math courses. And in addition to integers, we also have the data type long. This data type can represent larger integer than the standard integer data type. In particular, in C, it's 64-bit or 8-byte in comparison to just 32-bit or 4-byte when using an integer or an int data type. So we have the ganze Zahlen. Now we come to the float numbers. Float is just a number, but with decimal digits. In German, these are the Kommazahlen, so these numbers have Nachkommastellen. And if we need a more precise floating point number than a float, we can use the data type double. So what's a double? It just represents floating point numbers with the double precision. And now let's come to a term that you may have not heard before programming, and it's the string data type. It's just a consecutive sequence of characters, so some characters just concatenated, that is used to present some text, some words, or whatever you want to have in a sequence using single characters, whatever you want.
I have a question maybe for the chat. If one single character is 1 byte and I have a string with 5 characters, how big should it be then, this string? How many bytes?
That's a very good question. So maybe I would ask it back to the chat, but we have already the answer here. If you have a character with 1 byte and you have now 5 of these characters concatenated, it's just 5 times 1 byte, so you have a string with a size of 5 byte if you have 5 characters, for instance.
Yeah, and it's great, but it's technically not correct in C, but we will come to that. It's kind of a cliffhanger because it is 5, but it should be 6, to be honest. But yeah,
it is indeed a cliffhanger, but we'll see that when we use literally strings in C. Okay, so if we now move on, so we want to use a variable in our program, but we have to consider 2 things before we do that. We have the variable declaration and variable initialization. The variable declaration is the very first step. So we have to define a certain data type and also the name of the variable. So we have some examples here. We can define a variable named age, which is the data type int. We have, for example, a salary variable with the data type float, or a group with the data type character. And after we have now declared our variables, we can now initially assign a value to the defined variable, and this is then called variable initialization. So what happens if we do not initialize a variable? We will simply do not know, so to speak. It is unpredictable what will happen if we want to access a variable that has not been initialized yet. And also again, as you can see here, the initialization works like you declare your variable first. So we have the variable with the name age and the data type int, and assign a value. In this case, it's 22. And it's the same for other data types. Okay. And now a brief but very crucial practical tip. Please, throughout your studies and also throughout your professional career, use both meaningful and consistent names when you program. simply choose descriptive names that would clearly indicate the purpose of the variable. So what's the reason, or what value does it hold? And also maintain consistency in the naming convention you use. This not only helps yourselves when you read your code again, or if you want to use variables, or if you have a larger program, but it also helps others that might read and try to understand your code. It also helps in this case our tutors when they read your code. And one example we have prepared here, for instance, is if you want to store the height of David in a variable, we would, for example, declare a variable named David underline height, and this names then perfectly describes what we want to store, and also others will know the purpose for this variable's use. So what is stored in this variable.
Yeah, and by the way, we have also clearly defined the naming convention, so how you should name it. For example, with this underscore between the words. So you can find them all on our course website. In the assessment of your assignments, there we have defined how you should name your variables, how you should name all the different stuff we will talk about in the next few lectures.
Yeah, it's really important also.
And now are coming, as always, the questions: why like this? Why not like this? I know we cannot make everybody happy. So we will cut that discussion now. I'm sorry for that. We will cut it for now. It is like that. You have to deal with it. I'm sorry.
Yeah, and it's important to stick to some coding style consistently. And in this case, yeah, we have prepared this coding style, and please stick to it. Okay. So now we've heard of characters. It's one of the data types we've just learned. But how does the programming language work with these characters? How does it handle these characters? And now also we could define how these characters are represented by the computer in the programming language. And for this reason, we could just number the characters. Okay, yeah, we could definitely do that. But which characters do we really need? So please just write in the chat what characters we should definitely have when programming.
So you mean now not for writing our code, but printing out code, right?
Exactly. Having some characters really as data in the code. Yes.
So what would be interesting? So basically, when we go back, something like this here. Yeah. So we have our group in this case, and which type of information could we also need here? The alphabet.
We already have. Yeah, exactly.
Special signs and numbers, yes. Lowercase, uppercase is also very important. So yeah, the best thing is lowercase, uppercase alphabet, and 0 to 9. Maybe we would also need this special printable characters. Maybe we want to ask questions, make a statement, semicolon, percentage, whatever. Yeah.
But it's not only printable characters. Yeah, it's also non-printable characters. Okay, there are some obvious non-printable characters like tab or space, but also if you press the return button or if you press the delete button. So these are characters that need to be stored somehow. And for this, we have to somehow standardize the numbering. And one of these standardization, which is widely used, is the American Standard Code for Information Interchange, but we all just call it in short ASCII. It is an encoding format. It's basically a table that contains many printable but also non-printable characters. This means that this table is like a translation between characters that we could read, and their associated numbers that are used internally in the computer. And additionally, commonly used existing encoding formats, so extended ASCII tables, contain translations for 256 characters. And now you might wonder, why exactly 256? Why not 255? Why not 3000? Do you have any idea why this could be the exact 256?
Sorry, I was too fast.
Okay. But for the sake of time, yeah. Let's just explain it. So 256 is 1 byte or 8 bits, which means with 1 byte we can represent 256 different characters. So this is very convenient in this case. And this is required because the table is some kind of common language between computers. It's used for having a consistent interpretation between different devices, different platforms, so that they can understand each other. And if we now have a look at number 65, A, we can see the translation between the numbering and, in this case, the uppercase A. So if we use a variable that holds a character variable that holds the value A, it is represented as 65 internally. And this is also the case for any other characters that are represented here.
So a computer cannot really hold characters, it holds values, and we can interpret these values as characters.
Exactly, yeah. It's really like a translation between us as human or as programmers and the computer. So works like a translation between these two languages, so to speak.
Great. So that's all from characters and variables, but variables and characters are alone maybe are a bit simple. I don't know how to build a program like Spotify or YouTube with that. You need a bit more things, and you need operators. Operators are a very cool tool to work with variables indeed. So for example, you have the assignment operator, and we will now go through a few operators, not all of them. There is a huge list at the end of this section where we listed all of the operators, but some might you already have seen. Basically a few slides ago we saw that assignment operator. This assignment operator just assigns the value 6 in this case to the variable x. Then in the second line it assigns the value 5 to the variable y. And then we have one more, maybe a bit more advanced operator. We have now this x plus y, so this is an addition. It adds the value of y and the value of x and stores the result in z. So hopefully z now holds 11. If I program that correctly, this should work. So this is the arithmetic operator for mathematical operations. Of course, you can also use minus, multiply. You could also do like this. This is a division, so you divide x by y. But this has a problem, and the problem is when you have x, which is in this case 6, and y, which is 5, you want to divide 6 divided by 5, which is 1.2 if I recall correctly, and the result from this division would be 1, because you are dividing two integers. So this one is an integer because you declared as an integer. This y here is also an integer, you declared this integer, so the result is always an integer. you will have problems in this case, because even if you write here float because you want to be the result of floating variable, it will be just 1 and not 1.2, because you are dividing an integer by an integer. So yeah, to find a solution for that, the y or both has to be floats as well, then this would work. I know maybe it's not important for you now, but you will come to a point in programming where you get a funny result from a division, and this is then the moment where you should realize, okay, I'm dividing two integers. That's always the problem.
That's really a common pitfall, yeah.
Yeah,
also
it's very
encountered
common.
multiple times.
And it's very hard to find, because you would assume you have done everything correct, yeah. Another thing is so what we already saw is this binary operator we have a left part and a right part, and then there are unary operators where you have just one operand. So as you can see here, this plus has a left part and a right part, and this x, so I define here variable x is equal to 0, and then I can write x plus plus. So I only have one variable, not here left and the right side, and this actually increments my variable, and I can also say minus minus, that decrements my value, my variable. So in this case, x is 0 again. That's very helpful, and you will use that very, very often in future, even though in the beginning it might be a bit hard to read. But this is maybe the most, or one of the most used operator of all. And this unary operator has, a counterpart. So we saw this x plus plus, which is just an increment, and it's called a postfix increment. You can also write, for example, plus plus x or minus minus x, it's the same. And the difference between this prefix and postfix is the prefix is executed before other operations around. The postfix is executed after the operations around. You will see that in your next exercises. We will also have this in the weekly exercises. So you will see that, and I will highly recommend to just try it out, write your own programs after the lecture, and try a bit what are the values. So today, I think we will give you a good overview how to start, and you should be able to write your own first programs and trying out what are the values of these variables. And then you can combine arithmetic and assignment operator, and this is maybe the most confusing thing, because at least for me it was hard to understand in the beginning, because you can write int x plus equal 6, which basically means x is so x plus 6, and write then the result in x again. So it's basically this plus plus operator, but many times, in this case 6 times. But if you want to write it shorter, and programmers in general are very lazy and want to write as less as possible, so in this case you can also write it like this. But if it's for you hard to understand, of course you could also write it like this. The same works also for divisions and all the other arithmetic operators. By the way, I don't... One
question here. So we've just learned before that dividing two integers results in an integer, even if the result should or would be in float, the float value. What happens here? So if you divide y by 5, let's say...
It's an interesting question. It's a very interesting question. It depends, but in this case, it's also maybe not the best idea, because 5 would be an integer and you might get a bad result. It would work if y, for example, is 10 or 5. So the result then is always an integer, then it would work fine. But it is, for example, 6. You have the same problem as before. Here is 6 divided by 4, 6 divided by 5. So you have the same problem before. Nice spotted, yeah. And one additional thing we haven't mentioned is this semicolon here at the end. Do I really need this, Sebastian?
Yes, at least in the C programming language. So there are other programming languages that don't need a semicolon, but in C it's required to end every statement you write with a semicolon. So you could also, please don't do that, but you could also write all statements in just one line. If they're separated by semicolon, it's fine, but please don't do that. Please put every new statement in a new line. But it is required in C.
It's required in C, and then this is what I'm talking before. The compiler identifies if you are not ending your line with this semicolon, and it will give you a warning. Maybe I can show it to you also in online GDP. We had this hello Sebastian before, but let's change it to just having here in X is 4. Okay, it's again the wrong layout. Oh my god, how to change the layout? It's Julia's layout, and I don't get it how to change it. Anybody know how to change the keyboard layout from English to German? I think we need a new keyboard. Yeah, in the settings. Yeah, I know, but I don't want to open the settings now. It is control space, not here. No, it's not working. Windows space. I tried it already. Yeah, okay, Windows space. Thank you so much. Windows space.
Perfect.
All right. Okay, so let's execute that. And you can see the compiler in this case says you have a problem. It expected here this semicolon before this statement was executed. We haven't talked about that. Maybe we should delete it. But it needs here, let's rerun it again. It says again, okay, you need to have like a semicolon at the end. So when we write it like this, it then works. So it print nothing because we don't have anything printed out, but it at least compiled successfully. So when you have a statement or this error message with expecting this, you're missing a semicolon at the end, and then it works. All right.
Just a small thing, but it's very important. So to have a semicolon at the end of the statement. It's, sometimes you forget it, but at least when compiling it, you will probably notice it. Yeah.
I saw another question. What is, maybe we should delete this here. What is this include stdio? I think we also didn't discuss it. I'm sorry. This is basically code you can import from a library. It's called library. So basically somebody else already have written some code and you can use this code. And it stands for standard IO. So standard input output .h. In this case, it's a so-called header. And it's a library, or so in programming it's called library. And this is just basically another file where some code is already written. I don't need this for this kind of operation, but I would need it if I write printf hello, because this printf functionality is written in this library. So this would work, but if I remove the library, it says, okay, you have this printf here, but I don't know where this printf is written, so I don't know what to do with this printf. Give me a library, give me the code where this printf is implemented. And this is basically what you do here. In the beginning, it might be sufficient to use this standard IO library for all the input and output stuff. We will discuss further libraries in the next lectures, so you will get used to this kind of things here in the libraries. All right, let's continue with operators. There are many more operators. So relational operators, where you have a relation between a left and a right operand. In this case, 5 is smaller or equal to 4, and then store this result into a variable a. Here, this operator is so you can say, is 5 equal to 5, which is true, and then you can store the result in B. And what you also can do is A not equal to B, and store the result in C. So you can see here, maybe this is not a very useful example, but there are some operators and you can use it, and we will discuss that in the next lecture. You can use it for logical operations. You can write something like if and else statements. So if something is true, then execute this kind of code. If something is not true, then execute this kind of code, depending on the situation. In this case, if the number here is smaller than 0, so it's a negative number, print out it's a negative number. If it's higher, print out it's a positive number. And you can also combine these operators, and now it gets very tricky. You can say, for example, if C, so my variable, in this case, it's an ASCII B, it's greater or equal than A, and, so this is a logical operator, C, so this character is smaller or equal to C. Wow, that's hard to explain. To set, then, okay, it's a lowercase. Why does this work? So we've seen before the ASCII table, we have here a B, and this B is just another representation of the number 98. The A here is just another representation of the value 97. So you're basically comparing here 98 is greater or equal than 97, and 98 is smaller or equal than 122, because that's the set. So you can see here always when you write in this single quotes, this means that this is really the character, and if I don't write the single quote, it's meant to be the variable. But I have to admit, this variable name here is really not the best one. So I think somebody would give me a deduction when I submit something like this, but this is very hard. There are more operators like the bitwise operators, where you can combine it, and I think for the sake of time we will skip that for now, but you can have a look on your own, and maybe you also have seen it in other lectures before, but it's also possible to use these bitwise operators in C. And you could use this, for examples, for microcontrollers where you have only a little bit of memory and you need to save memory, or when you send something over a network. Another operator is the so-called address of operator, and we have seen before that a variable always has a memory location, it has a value and a data type. So we have talked about the data type, we've talked about the values, but we can also display with C the memory address. So we can see here, when we put this address of operator in front of an address, then we get the address, not the value, but the address in the computer. We will talk about that in a few slides, I think, what this here means. And there is a list of all the possible operators. This is just the first part. The second part is here. And this is basically like a guidance for you to start when to use what operator and which operator has or is executed first. So in this case, all of these operators here in the class 1 are operated first, then all this in this class 2 are operated next, and so on. So if you chain them, they are executed in this line by line, or in these groups from 1 to 15 in this case. All right, I know that was a lot about operators, and you do not have to know all of them from now on. In my opinion, operators is a lot trial and error, and a lot just trying things out. Does it work? So my recommendation would be go to online GDB after the lecture or in the next few days, try out a few operators, and do also our weekly exercises, and then you will get a feeling of how this operator works. Were there any questions about the operators here?
Not as far as I've seen.
Great, because we have 15 minutes left and still 3 major topics. So I think we should continue to make it in time. Output. What is output? We saw a bit of output already using this printf, right?
Yeah, so we have already used it, but without knowing it, what exactly printf does or what output is in general. So in general, we can use the console, for example, to output something we want. For example, we can use printf. It's a function. We will see in a couple of weeks in the lecture what a function is. That is used to display some text, but also display some text in combination with variables in the console. So the basic syntax consists of 2 different components. It's the format string, so the text that is printed, and also some format specifier, which we'll see in the next slide. And the second component is then 1 or multiple arguments. So we can just use the format string without any arguments, and the more common case is then to use a format string together with some arguments, or at least 1 argument. So we can just print hello world and don't use any format specifier and therefore no arguments. But the more common case is to use, for example, here ESP week. We assign or we initialize it with value 1 and then print it using this strange combination % and d. So what is this? Well, this is called a format specifier. Format specifiers are used, for example, when using printf, to print some variable that has a certain data type. So for each data type, or there are even more format specifiers, but each data type can be printed using one of these format specifiers. So I will not go through all of that, but the most important are %C for characters, %D for int, LD for long, F for float, LF for double, and S for string. We will also get to know %P for address in memory, and there are a bunch of others format specifiers which could be used but are not really necessary at the moment. And in addition to these format specifiers, printf also has some other cool features, let's say, because with the format specifiers you can also control the decimal precision. So if you only want to have 2 digits so zwei Nachkommastellen, you could use, for example, exactly here, %.doF, and this then reduces the number of digits right to the decimal point to 2 digits. This is quite useful in many cases. You will notice it in the practicals. And what is also a cool feature of printf is the output alignment. So we can reserve some space when we print something using printf. So this is just a very short example here. So if we want to align two columns when printing something, we can use a number between the % and the format specifier letter. And in this case, we can also use a negative number to have a space to the right and a positive number to have a space to the left. So the remaining characters that are not used by the variable are then filled by spaces, in the first case to the right, and in the second case to the left. So that's the most important information about printf. It's again like the operators, like a trial and error, and it's just a learning by doing.
One thing to highlight here, maybe, because it might come up, you might come up with, if I have something like this and I just want to write here the value of x, why not doing like this? So this would also be legit because I have here an x variable that just want to print x. So what happens now? It just printed x. So it really prints out what's inside the brackets here. So I cannot access the value of it. Of course, I can write it like this, yeah, and then it prints 4. But what if I change this value here? It still prints 4, obviously. So what it needs here is I want to have a string, really a text, x is equal to, then I cannot write here, I can write 5, but it's not a good practice. I need to write this %d to get the digit of x. So this here means take the variable and put the value into this position into the text. And then, great, it is 5. So this is very, very important to understand.
Exactly. Yeah, it's like something like a placeholder in the text that is then replaced by the value of the variable. Exactly. Yeah, thank you, David. But it's not only all about printing something, so it's not only about output. We also want to have some kind of input. And yeah, this is similar to printf actually. For that, we could use, for example, the function scanf. Again, we have a format specifier, in this case, %d, and an argument, in this case, number. But what's that before number? That looks strange. Why is there an ampersand? What is that?
Yeah, we saw it already. Yeah.
We saw it, yeah. But is there anyone in the chat that knows why we use this, or why it is required to use this? Yeah, it's the address of the number, and we will also use it a lot in the next weeks. It's required because we want to store the input of the user at the address of the variable. So every time you want to store some user input in a variable, you need to use the address of operator. And yeah, once you have read the input from the user, you can do whatever you want with the variable. You can again just print it using printf.
So how do I know that I need the address here?
You will know it if you then use the variable again. So yeah, maybe we could also try it out in online GDB. What happens if we do not use and then try to compile it?
Let's say I have a number here.
Exactly.
It's 4, and then use scanf. And like this number.
Okay, let's try to compile it.
Is it correct? It looks good. Oh, it looks good. I missed the address operator. Okay. Yeah, it says something weird about a star here, and you need something more. We will discuss that. But basically, what you always can do is look at this scanf definition, and there it says that you need this address operator to. Okay, it doesn't work on my keyboard again. I need to stop it, obviously. Okay. And now I can input something. Okay, it's not printed. Maybe we should add printf in the end. Entered number. That's the number. So we can enter a number, let's say t, and then we got entered number is 4. Interesting.
Yeah.
Have I missed something?
So you. Is it by?
As always, when you present something which is not prepared, you have an error here. I don't know what's the problem here now. Yeah, but this should also work if I don't declare it like this, because it should override the value. I don't get it. What's the problem now?
It's really strange. Yeah.
Yeah. I know it. I got it. Obviously. Obviously. I want to enter a number, and it's an integer declared. So we have to define it as character. We have to say it's a C, because C, then maybe we should change it to my char, because it is my character. So I declare a character, then I can enter a character, I read a character, and I output a character. And now it works. It is a T.
Perfect.
When I want to it has an input integer, then I need to declare it as integer. I want to read an integer, and I want to write an integer.
So print it as an integer.
In this case, 7, and then the entered number is 7. All right. That was the problem.
But that's a good hint for another function we could use. So when talking about characters, we could use the function getChar. So this only reads one single character, and yeah, just an alternative to scanf that could, for example, also read multiple characters. And so if you have a number, let's say 45, get character will only read 4. So this is the basically the difference between scanf and the function to get one character. And yeah, that's all about the output and input for now. And it's just really trying out stuff and also reading error messages and trying to fix these errors then.
Okay, so I think we just have 3 minutes time, and we have one topic remaining, but it's not really necessary for the weekly exercises. So maybe we can skip that and do this next week. And let me just go over there and skip these pages, these slides, and come to our conclusion. Because I don't want to take too much time, and we have enough time next lecture, so it will be the better choice, I think. So what we talked about today. Variables are stored as information, so we have a specific type, they have a memory location, and they have a value, of course. We have different types of variables: integers, characters, floats, doubles. We have seen many of them. We talked about the operators, so the different symbols that perform actions on variables. And we talked about printf and scanf, which are very important to like interact with the program. So we want to give something to the program as a user, and I want to take something from the program as output. So I can use scanf for input and printf for output. The last one is a small spoiler for what we want or what we wanted to do in the last topic, but as I said, we will discuss that next time. All right. Yeah, I think we are done for today. Anything you want to mention, Sebastian?
There's just one, I think it's a question: when do I need to initialize variables and when can I write, for example, int x? Yeah, it depends. It's up to you if you just first declare your variable using int x and then initialize, or if you declare it and initialize it in the same statement. But it's quite often the case that you declare it, maybe initialize it, and then use it at some point again and use another value for the variable. So it depends on the case. What you
but I would say especially in C, I would recommend to initialize it. And if you don't know the value what should be there, just initialize it with 0, because otherwise you don't know what's in there. Maybe I can show you that. When I have something like this, and I do not initialize, let's call it to be, have a better name, my number, and I do not initialize it, it will be, sorry, my fault again. So
yeah, that's true. At least in the C programming language is always safe to go if you initialize it.
So it is 0 in this case, but you cannot be sure that it's 0.
Yeah.
And it might be that you write something like, I don't know, x is my number divided by 2, whatever. So you don't really know what this is. It can be 0, but it's not guaranteed. And then you have another variable which is dependent from this. So you're getting more and more in trouble. And sometimes these values are really not 0. So I would highly recommend to initialize it always with a value, because then you know at least, okay, this is 0 at this point.
Exactly, yeah. So if you want to stay safe, just initialize it when you declare it.
Another question was, what does return 0 does here in the end? We had that before. It basically closes our program. So you can see here, program finishes with exit code 0 because we say we return our program with 0. So it exits with 0. When I write here return 1, you will see the exit code is 1. And sometimes you need that exit code for further analysis of the program. Maybe if the program crashes or had a problem, the exit code is different to when everything was fine. And we also have that in the assignment. We have a special section where we have defined in certain cases your program should end with the exit code 1 or 2, and if everything is fine, your program should end with the exit code 0. So this is basically, in the end, just one line defining the exit code.
That's again maybe a bit of a cliffhanger for the lecture about functions and then return values. So, yeah.
Definitely. One last question maybe, and also we need to write return 0 because main is declared as int, Right. Yeah, that's maybe one step further when we will talk about that when we discuss functions. All right. So yeah, thank you, Sebastian, for taking the time on your busy trip in Munich.
Thank you.
Wish you a very nice few days left. I think you return tomorrow or on Saturday.
Tomorrow in the evening, exactly. Yeah.
Okay.
So another day of conference tomorrow, and then heading back to Graz.
So next week, hopefully, you are sitting next to me again.
I hope so. Yeah.
Yeah, great. Very looking forward. I hope you also, found it interesting and have learned something for today. The weekly exercises will be published in a few minutes, I think in 15 minutes around about, and also the homework. So have a look at it, and you can also register for the coding session for next week then. Great. I think we are done for today, and have fun practicing and see you next week.
Yes, see you next week. Bye.
Bye.